Hey guys, this is going to be number 5 and number 9 on your homework. So we're going to talk about a couple concepts here. So first, all we have to do is identify the graph. So of x squared plus 6, it's squared, so we know we're going to have a U shape. Now I want to focus in on what this plus 6 does, and we'll get there in a second. But to identify the graph, the first thing you're going to want to do is just graph it on decimals. So here's the graph of it on decimals, okay? Now, as I look at it, I'll explain it out a little bit. I'll go full screen. We can see that we have a vertex at 0, 6. So when we go back to our page, only 2 of these are even possible. This one and this one, okay? These two don't work because they do not have their vertex at 0, 6, or the y-intercept at the same point. So we see that it's moved up 6 units. Now, if we're going to look between these two, we're going to look at some other lattice points. So remember, lattice points are these good points that cross through on our grid. So if I look through, I get another lattice point here and another lattice point here. So I know my graph also goes through 1, 7, and -1, 7. That's enough to make sure which one of our graphs work. So when I look, 0, 6, now you have to be careful because this goes up by 2s and this goes over by 1s. So this is actually at 1, 7 here, and then this side is at -1, 7. Okay, so this one is the graph of x squared plus 6. You can see here, yes, we have the right vertex, but when I get over to 1, I'm all the way up to 12. When I'm at -1, I'm all the way up to 12. Close, but not exactly what we wanted, okay? So now we're going to fill in the bottom part. So that was just me showing you when you have to identify the graph, you just graph this in decimals, but actually check a couple lattice points to make sure you're looking at the right graph. It could look like it, but that's just because of the zoom. Now we have to fill out the bottom part. So we want to compare this graph to x squared. So we want to compare this to x squared. So what we're going to do is go into our decimals and just graph x squared also, okay? So now we have x squared. And if I compare these, x squared is the original. That's called the parent function. It's just x squared by itself. What they're saying is, how did I get to the blue graph starting from the black graph? In other words, starting with x squared, what happened when I changed it to x squared plus 6? And I hope it's a pretty easy thing to see. I took this and moved it up 6 units, okay? And just to prove it, I'll look here. Let me take this. So 6, I'm going to show you as it incrementally goes up. Plus 1, excuse me. See how it shifts up 1, and then watch me do a plus 1 again. See how it's shifting up units? It's slowly getting up there until I get all the way up to plus 6. Okay? So that's a big concept for us to see right now. X squared, you can think of x squared as our base function, and in math will be called as a parent function, because the other functions come from that as long as they're parabolas. So what is adding just a number to the end of it does? It's going to shift it up 6 units. If I was subtracting, it would shift it down a certain number of units. Okay? So let's go back now to our decimals, our questions, and answer that. So the graph of G is a blank. Notice, f of x is the x squared. G of x is the x squared plus 6. So they're saying, how did f become G? The graph of G is we moved up and down, so we're talking about a vertical translation. Translation just means movement. Now, how many units did we move? Well, we went up 6. That's what that told us. So translation, 6 units, and then up of the graph of F. So X, let me just explain that looking at this graph again. The black one was F of X. Don't go by this, please. Actually, I'll change this kind of over this. I don't want anyone to be confused. So this was G of X, and this was F of X. And all they said, describe G of X as a change of F of X. Now they'll tell you, they'll be pretty straightforward on the questions, and this will come up on your air test 100%. So all they're making you understand is +6 means we had a vertical translation up 6 units. This whole graph was taken up 6 units, okay? Now, let's look at number 9. Number 9 is a lot like this. So first we have to identify the graph of G of X equals negative X squared plus 3. So G of X equals negative X squared plus 3. And hopefully you notice something, it's turned down. That's what a negative X squared does, okay? Nothing else will matter. If the X squared is negative, it points down. If the X squared is positive, it points up. Or you think of a smiley face. If X squared is positive, you have a smile. If X squared is negative, you have a frown. So what happened? It got turned upside down and then still moved up 3 units. So now we're just going to make sure that we can find this graph. So we know we have a vertex at 0, 3, and then we have a nice lattice point at -1, 2. And then we have a really nice lattice point at 1, 2. And if you wanted to, you could check out the x-intercepts as well. But this should be enough points. -1, 2, 0, 3, and 1, 2. So now, let's find the graph. Well, we know it can't be those ones because it has to be pointed down. And then the vertex was at 0, 3, so it can't be that one. So it had to be here. Okay? Now let's fill out what we're seeing. So the graph of G is some type of movement from F. So I'm going to go back and put it exactly like I did before. G of X was my new one. F of X is still just X squared, or the parent function. So how did we get to the blue graph from the black graph? Well, it is a reflection across the x-axis. All a reflection is, this should be the first time you're hearing it, a reflection is exactly you would think like a reflection in the mirror. So first they were x squared, and I'm going to draw this just so you can see it. Negative x squared. So you see in red, this is the first movement. This is the reflection. And then they're going to go up 3 units from there. That's what the +3 does. So you can think of these as all as control mechanisms. The negative on the x squared flips it or creates a reflection in the x-axis. And then we had a vertical translation because it went up, okay? And it went up 3 units. Up of the graph. Sorry, it took a second to find the word up. So I know there's a lot of stuff to put in here, but this is how they're going to ask you in these, so at least you have like a good model to go from. So make sure you keep referring back to this video if you need to. So the way we described it was, and I'm just going to use this picture to go through. we started with our x squared, which always is a U shape pointing up. We then flipped it, and then moved it up 3 units to create our new g of x, negative x squared plus 3 equals g of x. Okay? So hopefully that makes sense. If it doesn't, ask me. But this is the terminology that tells us what we did. And then going back to our graph, the negative caused the reflection, the plus 3 caused the vertical translation. Okay?